Hey, see this problem. This is 50 km per meter. This is C. This is A. This is B. This is RA. This is RB. This is 8 meter. This is 60 meter. This is 200 km. This is 150 km. Find out the horizontal thrust. Answer. Take a movement about a 50 into 20 into 30. Here C. Length of uniform distributed load of 50 km per meter. 50 km per meter length uniform distributed load is 20 meter. Then from the A to the center point of 50 km per meter, the distance is 30 meter. Here say this here 150 into 16. This can be the concavity downward. Plus 200 into 8. This 200 km, this is 8 meter. Then minus RB into 40. Then RB is equal to 850 km. R is equal to 500 km. Summation MC is equal to 0. Implies 850 into 20. You see here, this is 850 into 20 minus H into 8 plus 50 into 20 into 10 is equal to 0. Implies H is equal to 875 km. Then 3 hinged parabolic arch. This is 30 km per meter. This is H. This is theta. This is RA. This is RB. This is 24 meter. This is 4 meter. This is 50 km. This is 6 meter. This is H is equal to 307.5 km. Term bending moment, horizontal thrust, radius shear at 6 meter section from left side support and draw the bending moment error. RB is equal to 127.5 km. Taking moment about a summation MA is equal to 0, which implies minus RB into 24 plus 50 into 18 plus 30 into 12 into 6 is equal to 0. Implies HA is equal to HB is equal to H is equal to 307.5. QX is equal to V cos theta minus H sin theta. X is equal to 6 meter. Q theta is equal to tan theta. Y is equal to 4yc by L square into L minus X, which is tan theta is equal to dy dx is equal to 4yc by L square into L minus 2x is equal to 1 by 3, which implies theta approximately equals to 18.43 degree. Actually, y is equal to 4yc by L square into x into L minus x. Dy dx is equal to tan theta is equal to 4yc by L square into L minus 2x. Here, dy dx is equal to tan theta is equal to 4yc by L square into L minus 2x. Find out nx, the normal thrust, bending moment at 6 meter, 102.5 meter, used by the beam. Vx is equal to 6 meter is equal to 2825 minus 30 into 6 is equal to 2645. Vx is equal to 8 meter is equal to 2825 minus 30 into 8, maybe 2825. This is theta. This is dx. This is dy. This is positive. This is negative 157.5 kilonewton. Hey C. This is W per unit meter. This is length L. This is length L by 2. This is X. This is length L by 2. This is H is equal to W L square by 16H. This is WL by 8. Find out the horizontal force and maximum bending moment. Order M V curl square delta by curl X square. Theta curl delta by curl X and delta, which is delta. Summation Mx is equal to 0, which implies 3WL by 8 into X minus WL square by 16H into Y minus WX by 2 is equal to Mx. Then curl Mx by curl X is equal to 0, apply condition. Then X is equal to L by 4. Here X is equal to L by 4. Next is the SA-1 class with 3 hinged circular arch. This one is the hinged. This is O, this is A, this is C, this is B, this is D, this is E, this is F, this is theta, this is L by 2, this is L by 2. Then here it is Y, this is F, this is X. Y is equal to 4yc into X into L minus X by L square. OG square is equal to OF square plus GF square. जिसका एमिति होची this one is r square is equal to r minus yc plus y. What is r minus yc plus y? Note here, r minus yc plus y is OF, where and GF is x. Then under root r minus r square minus x square is equal to r minus yc plus y, which implies y is equal to under root r minus x square minus r minus yc. L into L by 2 is equal to yc into 2r minus yc. Then L square by 4 yc is equal to 2r minus yc, which implies 2r is equal to L square by 4 yc plus yc. Then implies radius is equal to L square by 8 yc plus yc by 2 OA square. Then OA square is equal to OD square plus AD square, which implies r square is equal to r minus yc का whole square प्लस L by 2 का होल स्क्वायर. OA square is equal to OD square plus AD square, which implies R square is equal to R minus YC का होल स्क्वायर प्लस L by 2 का होल स्क्वायर. 3-inch circular arch of span 60 meter and center rise of 4 meters subjected to point load of 100 kN and 80 kN. Here is the diagram. This is A, this is 4 meter, this is 4 meter, this is 4 meter, this is 4 meter. This is 100 kN, this is 80 kN. This is O, this is 3.16, this is 4 meter, this is 3.8 meter, this is 6 meter, this is 4 meter, this is 6 meter. Find out the reaction, bending moment, normal thrust, radial shear at 6 meter from the left side support. VA is equal to 9.90, VA is equal to 95 kN, VB is equal to 85 kN. Horizontal reaction H is equal to 90 kN. Maximum bending where point force actually acts. Bending moment at S is equal to 4 meter. Y is equal to under r square minus x square minus r minus yc. R is equal to y square over 8yc plus yc by 2. This is r is equal to L by 2. This is A, this is B, this is A, this is B, this is A, this is B. R is equal to y square over 8yc plus yc by 2. Y is equal to 3.16. 2 implies r is equal to L square over 8yc plus yc by 2 is equal to 10 meter. Bending moment at x is equal to 4 meter is equal to 95.6 kN per meter. Tangent theta is equal to dE by CD.